right, lesson 5.4 is solving compound inequalities. And up to this point, we have solved multi-step inequalities. And now we're going to look at a compound inequality, which consists of two separate inequalities that are going to be joined by the words and or the word or. So first we'll look at the and. The graph of a compound inequality with and is called an intersection. So at an intersection, things come together. Lines can intersect. Cars can come together at an intersection. So here we have x is greater than -2, open circle, shaded right. X is less than or equal to -1, closed circle, shaded to the left. This is an and, so we're saying both of these things are true. So this is true and this is true. Well, we could flip this around. If we flip-flop this, then -2 would actually be less than x. We can't, like, you don't flip-flop an equal sign, but when you move the variable and the number, you have to flip-flop the inequality sign. So this is the same thing. -2 is less than x, and x is less than or equal to -1. So here it is as an inequality statement, one statement right here, and here's the graph. They are intersecting, they come together. And I want you to write this down. With an intersection, it'll always be in this form, where you have the smaller number, less than, or it could be less than or equal to, the variable less than, or again, less than or equal to the larger number. Ugh. And then we have, the or. The graph of a compound inequality with or is called the union. They are not going to come together. This is true or that is true, not both of them. So x is greater than or equal to 0, closed circle, shaded right, or x is less than -1, open circle, shaded left. So when you write that, you just write it as we have it up here, making sure that you put in your word or, and when we put them together, there is no coming together in the middle. They're going to be shaded away from each other. This is true or that, so away from each other. This is true and that is true, so towards each other. So let's go ahead and take a look at a couple of these. Here they want us to translate the verbal phrase into an inequality, then graph it. All real numbers, I'm just going to use the variable x to denote all real numbers here, because the real number symbol is not a variable, so I'm just going to use the x. They're less than -1 or greater than or equal to 4. So it's an or, so they're going to be shaded away from each other. So I have x is less than or equal to -1 or x is greater than or equal to 4. So I'll just start with the 0, -1, -2, 1, 2, 3, 4. I'll put it up to 5. Both of these have equality, so I'm going to use an open circle. Here's an open circle. X is less than or equal to -1, so shade to the left. Or x is greater than or equal to 4, shade to the right. And there it is. Union. Union. All real numbers that are greater than or equal to -3 and less than 5. This is an intersection because they're going to come together. So both things are going to be true. So we have -3 is the smaller number. Remember I said let's go smaller number, inequality, less than or equal to variable, and then less than or equal to larger number. Here it says greater than or equal to. Well, we know we have to write it less than or equal to, because if we flip-flopped it, x, the real numbers, would be greater than or equal to. And then less than 5. So I have to go -3 to +5. Whoops. My -3 does get a closed circle. My +5 gets an open circle, and I'm shading in between. So there you have it. Okay, let's look at this one. Write and graph a real world compound inequality. A crane sits on top of a camera car and faces toward the front. The crane's maximum height and minimum height above the ground are shown. Write and graph a compound inequality that describes the possible heights of the crane. So it looks here like the crane can go between 4 feet and 18 feet, including the 4 feet and the 18 feet. So this is going to be an intersection because it can be any of these distances in between. So I will write 4 is less than or equal to x is less than or equal to 18. Then when I go to graph it, I'll go down here 4, oh, come on, 6, 8. And that's good enough. And they're both going to show equalities, so closed circles, and shaded in between. All right, in some cases you're going to have to solve the compound inequalities. So here, this is with an and. So I like these because I can solve them simultaneously. I want to solve for the x, so I'm going to subtract the 5 all the way around. So I end up with negative 3 is less than x is less than 4. And it does work out smaller number and greater number down here. So when I graph these, I'm going between negative 3 and positive 4. And both of them have an open circle. Negative 3, positive 4, shade in between. Let's try a couple more. So the first thing I want to do here is subtract the 4 all the way around. So I get 6 is less than or equal to 2y is less than or equal to 20. And now I divide everything by 2. So I get 3 is less than or equal to y is less than or equal to 10. And then you would graph this. It's not asking me to graph it right now, so I'm not going to, but you would do a closed circle on the 3, on the 10, shade in between. Let's try this one. We'll add the 1 all the way around. So I get negative 6 is less than negative z is less than 4. But I have to divide by negative 1. And don't forget, when you divide by a negative, the inequality signs change. So I have positive 6 is greater than z is greater than negative 4. Now remember, this is not in the correct form, because the correct form should have smaller number, less than variable, less than larger number. And it does work that I can flip everything, flip the signs and flip-flop the values. So when I graph this, I would have an open circle on negative 4, open circle on positive 6, and shade in between. Now we're just going to do the same thing, but we're going to graph them, we're going to solve them with an OR. So when you have an OR, basically you're just solving two separate inequalities, one at a time. So I'll subtract the 3, I get 2x is less than 9, divide by 2, oops, 6, I was looking at the 9, and x is less than 3. Or 3x minus 6 is greater than 12, add the 6, 3x is greater than 18, divide by 3, x is greater than 6. So this or that. So we'll go ahead and graph this. This is a union So I need to go 3 to 6. I'll do a couple on there, one on each side. This will be an open circle on 3, shaded to the left, and an open circle on 6, shaded to the right. So again, they don't meet in the middle. This is true or that is true. Let's try this one. I'll subtract 1. So 4c is less than or equal to negative 4. Divide by 4 and c is less than or equal to negative 1. Notice I did not flip the inequality even though I have a negative up here. It's because I did not divide by the negative. So or, up here I'll add 3. So I get 5c is greater than 20. Divide by 5 and c is greater than 4. So don't forget you need your or. So c is less than or equal to negative 1, so closed circle shaded to the left, or to the right, yeah, to the left, and c is greater than 4, open circle shaded to the right. So these are both examples of unions. Last one. The Mars exploration rovers Opportunity and Spirit are robots that were sent to Mars in 2003 in order to gather geological data about the planet. The temperature at the landing sites of the robots can range from negative 100 degrees Celsius to 0 degrees Celsius. They want us to write a compound inequality that describes the possible temperatures in degrees Fahrenheit at a landing site. Solve the inequality, then graph it, and then identify 3 possible temperatures in degrees Fahrenheit. I did put in here that we need to use the Celsius to Fahrenheit conversion formula. So Celsius equals 5/9 times the quantity Fahrenheit minus 32. And we're going from negative 100 degrees to oops, 0 degrees. So when I solve this, the first thing I want to do, I don't really want to distribute 5/9. So what I'm going to do all the way around, oops, let me get a color, is I'm going to multiply everything by 9/5. And so that will eliminate this. This is going to give me 5 goes into negative 100, negative 20 times. 9 times negative 20 is negative 180. Come on. Less than or equal to, I've unlocked it, so f minus 32. Less than or equal to, I still have 0. Now this makes it much easier. Since I got rid of my fraction, I just add 32 all the way around. And when I have the negative 180 plus 32, I get negative 148 degrees, less than or equal to Fahrenheit now, less than or equal to 32. So these are degrees Fahrenheit. So now I put it on my number line, and I'm going from a negative 148 to a positive 32. So I'm going to end up, well, let's see, if I go negative, let's go 150, and I'm just going to go in 50s and estimate this. So then I will put approximately where this is, so negative 148, we'll say right around there, and positive 32, 25 would be in the middle, so we'll say 32 is right here, and we'll shade in between. Now the last part says identify 3 possible temperatures. So it's anywhere in here. So I can say, for example, negative 100 degrees Fahrenheit, 30 degrees Fahrenheit. Again, anything in here. Negative 27 degrees Fahrenheit. Those are just 3 possibilities. All right. Now, if you would like to go ahead and start this assignment, this is lesson 5.4, page 326 to 329. Problems 1, 2 to 8, 10 to 26 even, 28 to 36, 38, 41, and 42.